All right, everybody. Today we're going to talk about terms, variables, exponents, and coefficients. And we're going to start with the whole component of that. I give you an example of 2xy cubed, or power of 3. And if I give you the whole thing, 2 is the coefficient, the number in front of the variable. X and y, they are called the variables. Okay, and the exponent of y, or a number above y, that's called the exponent. The entire thing, 2xy cubed, is called a term. You just have to remember the components of a term and an expression. All right, as an example, I gave you minus 3y squared z cubed, or z to the power of 3, and minus 3 is the number in front of the variables. That's called the coefficient. And and yz variables, 2 and 3, they're both exponents. All right, and let's come back here as another example, and I just used a very famous circle area formula that most of us are familiar with. Is pi r squared. So a is the variable, the area value. Pi, you have to be careful with pi. Pi, even though it is unique, but it's actually a number. It's an irrational number. So that is actually a coefficient in front of the variable r, and the r was the radius of the circle, and 2 turned out to be the exponent. Okay, so and then depending on what r is, we can plug a number in and then get the value for the area of a circle by multiplying it, by squaring it first and then multiplying it by pi. All right, and then next part is the integral exponent. We need to look at the mechanics of that, all the components. So if I have a to the raised to the exponent of n, or n is on top, a is in the bottom, n is called the exponent, a is called the base, and the entire thing is called the power. Now what that means is that if I expand a to the n, it's going to look like this: a times a times a times dot dot dot, and it goes n times. Because of this n here, there are n number in here, so there's n factors of a. All right, and that's how the expanded form of any power is. So let's have an example. Let's suppose we have minus 3 to the power of 4. We're going to write the expanded form. So minus 3 is the base. We have to multiply it by itself 4 times. I'm not interested in actual the value of minus 3 to the power of 4. I just the expanded form. That's all it's important right now, so we can get used to that. The other way is that can we go the other way, like writing it in compact form. So if I write down minus 1 times minus 1 times minus 1, what is that equal to? Well, that is the base is minus 1, and how many times is being repeated? That's the exponent, 3. All right.